All right, future architects, if you're prepping for the AREs, you know that climate responsive design is, well, it's a big deal. So today, we are going to crack that code. We're going to demystify the whole thing and give you exactly what you need to nail those questions. So let me guess. Are you struggling to keep all the design strategies straight? Like, what's the difference again between hot and humid versus hot and dry? It's a classic trip up. Or you're just wondering, what do the test makers really want when they ask about a cold climate? Yeah, if that sounds familiar, you are in the right place. We're going to make this super, super clear.
Okay, so here's the game plan. We're going to hit cold climates, then hot and humid, hot and dry, and temperate climates. And at the very end, I've got the ultimate ARE cheat sheet for you. Sound good? Let's get into it.
First up, cold climates. We're talking about how to keep all that precious warmth in the building. The name of the game is defense against the cold.
So the primary goal here is pretty simple. We've got to cut heat loss, block that biting wind, and soak up as much of that winter sun as we possibly can. Think of it like building a thermal fortress. Everything we do is defensive. So how do we do that? Well, first, we go for compact shapes. Think row houses or clustered buildings. Why? It's all about minimizing the surface area. The less skin the building has, the less heat can escape. Simple, right? Then we orient the building with its long side facing south, east to west, to just drink in that winter sun. And on the flip side, we keep any openings on the north and west sides super small to protect from cold and wind. And on the site itself, we use tight windbreaks to the north and west. It all works together. Okay, so for the ARE, these are your magic words. If you see compact, cluster, row houses, windbreaks, small north/west openings, ding, 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 your brain should immediately scream cold climate. These are the dead giveaways that the design is all about hunkering down and saving heat.
All right, now let's do a complete 180 and jump into hot and humid climates. You can forget everything we just said about a thermal fortress. Here, it's all about keeping things cool and breezy.
In this climate, your biggest enemy isn't just the heat, it's that sticky, oppressive humidity. So the goal is totally different. We want to maximize airflow, get a breeze going through the building, provide tons of shade, and of course, keep all that tropical rain out. And the way we do this is, well, it's beautiful actually. We design buildings that breathe. We use long, narrow floor plans to get fantastic cross-ventilation. We even lift buildings up on stilts to catch the wind and separate them to create breezeways. And the roof? It becomes this giant umbrella with huge overhangs and verandas to keep you shaded and dry. Light-colored roofs are a must to reflect that sun. So, back to the exam. When you see phrases like narrow plans, buildings raised and separated, or anything about aligning to prevailing winds and having large shaded openings, you know exactly what they're talking about. This is your classic hot and humid solution. It's all about being open, lightweight, and breezy.
Okay, next up is a different kind of hot and dry. Think deserts. And guess what? The strategy flips on its head again. We're going back to a defensive design, but it's nothing like what we did for the cold.
The big deal in hot and dry climates is the huge temperature swing. It's scorching hot during the day and can get surprisingly cool at night. So our goal is to minimize that brutal sun exposure during the day and use the building itself, its thermal mass, to soak up the heat and then slowly release it when it gets cold at night. So what does this look like? We're talking compact, inward-facing buildings, often built around a shaded courtyard. The walls are thick and heavy. They're like a heat sponge, absorbing all that daytime sun. Windows are kept small and are deeply shaded. And when you put these buildings together, you create these narrow, shaded streets that act like cool urban canyons. Exam tip time. See the word courtyard, or thick, high-mass walls, or small shaded openings? That's your signal. It's a hot and dry climate. The building is basically a cave protecting you from the sun. Pay attention to this one, because this is where so many people get tripped up on the IRE. Hot and humid versus hot and dry. It's super simple when you see it like this. Hot and humid is all about being porous and separated. It's open, it's lightweight, it wants to catch the wind. Hot and dry is the opposite. It's compact and inward. It's dense, it's heavy, it's protecting itself. One breathes, the other bunkers. You have to know this difference. Okay, last but not least, let's talk about temperate climates. This is where a lot of us live. You get a little bit of everything. Hot summers, cold winters, so the design has to be a master of balance. The whole goal here is to design a smart, adaptable building. It needs to be a bit of a chameleon.
In the winter, we want to let all that good solar energy in. But in the summer, we want to block it. We want to catch a cool summer breeze, but block a harsh winter wind. It's all about that seasonal balance.
So the strategies here are kind of a greatest hits album. We still stick with that great east-west orientation for the building's long axis. We use moderately compact forms, often with south-facing courtyards to trap winter sun. But the real genius move? Landscaping. Specifically, deciduous trees. They're nature's perfect shading device, full of leaves to block the summer sun, and then they drop them in the winter to let that same sun in to warm the building. It's brilliant.
And for the test, your keyword is balance. Look for anything that talks about seasonal adaptation. Deciduous shade is the #1 giveaway. But also phrases like block winter winds, allows summer breezes. Anything that shows the building has to do 2 different things at different times of the year, that's your temperate climate.
All right, we've gone through all 4 climates. You're probably thinking, that's a lot to remember. And you're right. So now let's put it all together. This is your ultimate RAE cheat sheet.
Seriously, screenshot this slide. It's everything in one place. Just look at the logic. Cold climate goal, cut heat loss. The strategy, compact massing, small openings. Hot and humid goal, maximize airflow. Strategy, separated massing, large openings. See? The form, the massing, the openings. It all directly follows from the primary goal for each climate. It just makes sense.
And if your brain is totally full and you can only remember a few things, let it be this. That east-west long axis is almost always a good idea. But the big 3 are hot, humid equals porous and separated, hot, dry equals compact and inward, and temperate equals balanced. If you can just lock those 3 phrases in your mind, you'll be able to reason your way through most of the questions on the exam. I promise.
So look, yeah, you've mastered the textbook climates for the test. That's awesome. But the real question is, how are you going to use these principles to design for the climates of tomorrow? Because that's the whole point, right? This isn't just about passing an exam. It's about becoming an architect who can design smart, resilient buildings for a world that's constantly changing. Now go crush those exams. You've totally got this.